Good afternoon, everyone. Let's get started because I think it's about time. 2:30. Thank you all for coming. My name is Anant. I work at a company called Firebase. We make a real-time data store. You put JSON objects in and you get them out. Simple as that. But that's not what I'm going to talk about today. The topic is building JS APIs for browsers. And in hindsight, I probably should have picked a better topic because I don't think it reflects the content. So hopefully some of you read the description to get a better idea. So I'm not going to cover what are the best practices to make an API, or like if you're thinking about building a JavaScript API and stuff like that. What I'm going to cover is just a random grab bag of things that you need to be aware of if you're trying to build such an API, especially in terms of inconsistencies between various different browsers and some of the subtleties that you need to be aware of if you're thinking about doing anything that's browser related. And it's also not going to be comprehensive, so I'm just going to skim through some high-level topics and just give you a flavor for what are the kind of inconsistencies that you can expect in browsers in terms of how they expose certain APIs and so forth, and what you can do to work around them. And also just give you a kind of taste into if you're thinking about building a new web app or building a new JavaScript API, what are some of the things that you can rely on to work reliably across browsers, and what are some things that you need to be a little bit more careful about. And I would also like you, if you have questions that are relevant, that particular, like don't wait until the end, just to ask them immediately, because again, I'm not going to be comprehensive about all the different APIs and so forth, but if you want to dig deep into any one particular topic, please feel free to do so when we're discussing that particular API or whatever. So yeah, so a little bit more about me. I think so. I work at Firebase before now, but before this, I worked at Mozilla, where I spent a bunch of time working on various different browsery web experiments. And most recently, I worked on WebRTC a whole bunch. That gave me a lot of insight into how APIs are standardized and how they're implemented in browsers, and why a lot of the issues that you see in terms of API incompatibilities between various different browsers, how they come about, and stuff like that. So we'll talk a little bit about that as well in the talk. So great, so let's get started. So you all are here because you believe in HTML5, so you're obviously familiar. There's at least 5 major different browsers, depending on how you count, whether you want to count mobile or not as separate, and like 3 major rendering engines out there. And browsers are incredibly complex pieces of software. So they typically run into millions of lines of code. The renderer is not trivial. Definitely as complex, if not more, as an operating system. So it's a non-trivial piece of software, and as a result of that, combined with documentation on specs. So there's the W3C and IETF that typically standardize web-related standards and APIs. Those standards continue to evolve, and some of them are not fully spec'd out. There's always some ambiguity into what something actually means. Different people think different APIs need to do different things. So when you combine all of that, you get this kind of environment that you see today, which is there will often be subtle incompatibilities between how APIs work from one browser to another. And that's just a result of browser complexity. And there's really nothing that we can do because it's a very complex system, and it's not an easy problem to solve. It's not always possible for you to define a spec down to the letter to make sure everyone implements it the same way. So we're left with basically just these minor incompatibilities, and I think the way that we have dealt with it as a community is very good. So we have jQuery, which kind of led this initially. It's like, okay, the DOM is really not compatible. Like, there's so many small ways in which the DOM API differs between various different browsers, and jQuery was kind of the first one to unify all of these and give you a simple, elegant interface that you just use jQuery, and then you didn't worry about what is the actual end browser that your user is using. And so we're kind of seeing this pattern repeat itself. So jQuery did this for the DOM, but there's a lot of things that jQuery doesn't cover, which is what we're going to talk about today. And hopefully some of you in this audience will be the people to write these libraries that fix things in all of these things that I've enumerated here. So some of the things that I'll cover, and again, I'm not going to go deep into any one of these, but if you have any questions, please feel free to raise them as you go. So we'll cover some some fun bugs about the event loop and how that works. In browsers, we'll talk a little bit about iframes and how to do cross-subdomain XHRs. We'll talk a little bit about WebSockets and where that's at and what you can rely on, what you can't rely on. We'll talk about ways to do audio in the browser. Finally, we'll go do WebRTC and graphics and so forth. So let's go through these one by one. First one is the event loop. So most of you may know this. JavaScript is single-threaded, so there's only one thread. There's no concurrency. So from a programmer's perspective, it is somewhat simple, but I would caution you to not rely on that. If you think that it's single-threaded, think again. There are several things that can actually cause the event loop to spin. So the first thing to be aware of is if you call window.alert in Firefox and you had some callbacks that were registered beforehand, that will actually cause them to get triggered, even just because alert spins the event loop. And this is just a bizarre bug, which is just again, like I said, browsers are incredibly complicated, and this is actually just an artifact of how Gecko is architected. And it's not a trivial bug to fix. The bug link is there. It's I think almost 2 years old at this point, and so it's definitely not easy to fix. So it's definitely something to rely on. So I think in my experience, the best thing that you can do is whenever you're calling out to user code, don't assume anything about the single-thread nature of JavaScript. You always assume that if you're calling out to some user code, which may end up calling window.alert, then it will cause the event loop to spin, and so you might get some triggers in callbacks that you may have registered for any pending network requests or pending IndexedDB or anything, any asynchronous APIs that rely on the callback kind of behavior. Related to this, and this is not on the slide, also just as a general design pattern, when you're writing code that takes callbacks that is asynchronous in nature, it is kind of a lot of people make this mistake of if you have the data ready, you will invoke the callback immediately. Don't do that. So this is another tip. So if, for example, you're having some kind of network API and you cache network the data, and so when someone requests data from you, you're like, oh, I have this data right here. I'll just invoke your callback right away. Don't do that. You need to wrap that callback in a set timeout to ensure that the callback is called on the next event loop. And I think that is the general understanding amongst people that will use your API. So just another thing to think about when you're building your API. And definitely, so you play nice, but don't expect the world to play nice. So you always make sure to call your callbacks on the next event loop using set timeout. But when you call out into user code, don't rely on that behavior. Just another little piece of trivia. So window.showModal this is actually a function hopefully most of you don't know it. It's very, very ancient. It was first implemented by IE. But this function is especially funny because by spec, it is expected to spin the event loop. So that's just how it was specified. And it's very odd now, but it wasn't odd then, when it was spec'd way back when. So that's kind of the summary about the event loop, some summaries and a tip that you can hopefully find useful. Let's move on to iframes. Did anyone have a question? Yes?
So you mentioned wrapping callbacks calls in set timeout?
Yes.
So that's if you want to call someone callback within your own code?
That's right. So if you have an API that takes a callback as an argument, don't call it immediately, even if you have the data at hand.
That's just...
So that's to make it consistent, right? So a lot of the times it might be easier to show with code, but if I'm a user of your API and I call your function and pass it a callback and I have a line just after it, I might have assumed that that line is going to execute before the callback gets invoked. And that promise will be broken if you call the callback right away, because then it's going to be called before the line that came after your function call gets called. And so just as a general API cleanliness, you always wrap it in set timeout, even if you have the data already cached. And at worst case, set timeout with 0 just means it's going to be on the next event loop, so it's not going to be very far out, but it will at least keep your API consistent and clean. That's a great question. OK, so iframes. So the reason I want to discuss iframes, iframes are pretty standard. You can use iframes reliably across all browsers. There's no trouble calling document.createElement iframe and then appending it. That's definitely not the problem. But there are issues when you are trying to do cross-domain XHR, which is why a cross-subdomain XHR, which is mostly the typical reason you do iframes, is I've seen a lot of APIs these days they will have, to implement long polling or comment, they will have a subdomain on their site that says, okay, subdomain.mydomain.org, and that's where they serve their long polling stuff. But your main app is actually served from either a different domain or just your main domain like mydomain.org. And so typically you create these iframes, and sometimes people get confused. Oh, it's not working. It's not. So I just want to give you guys some like basic rules on how XHR works. What are the security rules that browsers enforce? So the first rule that browsers enforce is both the domain and the port have to match for your XHR to succeed. Otherwise, it's going to raise a security error saying, okay, cross-domain XHRs are not allowed, unless the server, of course, explicitly has CORS headers and so forth. But we're not going to get into CORS or any of that. If you want to exempt your API from cross-domain restrictions, then you can serve certain headers. But we're not going to get into that. So in this case, it's like a regular server. There are no CORS or anything like that. Both the domain and the port have to match. So if you're opening an iframe into a subdomain, and a subdomain actually doesn't match the port. So like x.y.org is not the same as y.org. So the browser treats those two as different domains, and it's going to reject your. What is possible, though, is when you're creating a subdomain into x.y.org, it is possible for JavaScript to set the domain of that iframe to any domain in its parent. So if you are serving an iframe x.y.org, you can elevate your subdomain or your iframe's domain to y.org. And typically, you do that by setting document.domain. To make things more interesting, document.domain equals document.domain is also not a no-op. And I will tell you why we use that. Oh, this image is not shown. Let me see why. I'll just show you the image here. Okay. Scheme also, yes. Very good point. So HTTP and HTTPS are also two different things. So let's assume that you are always over HTTPS or always over HTTP. So let's take the first case here, which is, okay, so the top document is mydomain.com, and it's served over port 80. Let's assume that it's HTTP. And your JavaScript from the top document creates an iframe on sub.mydomain.com port 80. So port 80 is the default. That's what the browser is going to set it to. Now, the first thing you need to do is for sub.mydomain.com to be able to do an XHR to mydomain.com is it needs to call document. So iframe doc.domain, that's where you say. So that's the inner iframe. It needs to set its .domain to mydomain.com. And the browser allows that because that domain is a parent of the domain that it originally had. And so that's the first step. And now what's going to happen is, so another interesting piece is the browser actually doesn't let you set the port explicitly, but what it does is when you call .domain, it will set the port to null. Don't ask why. Again, this is like implementation details / things that shouldn't actually be exposed to the browser, but they are, because they are complex pieces of software. So now what happens is, okay, so you have the domain for the iframe set to mydomain.com with the port null. And so now the port doesn't match. The port is now null at the bottom and 80 at the parent, and so you still can't XHR out. And so the final step there, and which is why document.domain equals document.domain is not a no-op, because just by the mere fact of assigning document.domain, you are setting the port to null, which is what happened in this case as well. And so in the final step, you have mydomain.com null and mydomain.com null for both. And so now you can finally do the XHR. So you need to do a little bit of dance here if you want to do long polling or just regular XHR to a subdomain or from a subdomain to a top-level domain. So a lot of people, they get confused when they write code and it doesn't work, and they blame the browser. Oh, it's like security. And so just remember this neat little trick to get that done. So again, like the whole point of the talk is for helping you cope with these browser incompatibilities. I realize that it's not an ideal thing, and browser vendors continuously try to make the API simpler. But I think this is the best that we have that we can do given the tools that we have, which is what also makes the web really powerful is even though there's all these kind of inconsistencies and stuff, and hopefully other people will solve this problem for you and give you an elegant API, it still gives you an immensely, you can reach millions of people regardless of which browser they're using, which is really powerful. So I think going through all of these like dance is actually worth it at the end. So that's the code snippet there that does, create an iframe, you set the source to a subdomain, then you call .domain on it, and then you also call .domain on the parent. So that's not all. So after you've done all of this, now you want to close the iframe. Let's say you're done with long polling and you want to tear down the session. Again, you need to be careful. So main culprit here is IE. So IE has this weird artifact where if you close the iframe and even just remove the iframe from the content of your document, it will continue to execute JavaScript that was loaded in the iframe. And this could cause a number of problems depending on how your code is structured. And most typically, you will not want this. So again, another tip if you're targeting IE, one way to do this is just to call .innerHTML and just remove the content of the iframe, so all the script tags and everything gets removed, and then remove your iframe from the parent document. And so now you can be guaranteed that no code is running from the iframe.
Is this the case in IE11?
I don't know about IE11. This is definitely the case IE9. In fact, I haven't even tested IE10. It may have been fixed since then. But IE9, which is still reasonably modern, still has this little artifact. So definitely watch out for that. The other thing that typically people will want to do when they want to close an iframe is send some kind of shutdown sequence to their server to say like, hey, I'm a client, I'm now going offline, or you want to send this last message. And most browsers will let you do this except for Opera. So the summary there is don't rely on the client saying a goodbye. Because the only way you can send a goodbye is to have some code run in window.onClose, so which is basically when the window gets closed, you want to run some code. And most browsers will let you run code, and most browsers will let you do an XHR at the last moment just to say like goodbye or something like that. But Opera won't let you do this.
With Opera switching to blanks is still an issue?
I actually don't know. That's a good question. That may not be an issue if Opera switches to blank, because WebKit didn't have this bug, and if they inherited from that, this may no longer be an issue. But if you're targeting pre-Blink Opera, then something to be aware of. The other thing is also for long polling. This is relevant for long polling. If you're keeping an XHR connection open with your server just to get notified, like a push notification, or whenever the server needs to tell the client something, this is how you do it in long polling. You open a connection and you just leave it open even if the server doesn't have any data right now. It might later on, in which case it will send the data, then you can reopen your connection. That's how long polling works. But Opera has a 30-second timeout in XHR. So if you open an XHR and there's no data going back and forth, after 30 seconds, Opera will terminate the connection. And it's very hard to debug. You're like, oh, what's going on? So just something to be aware of. So make your long polling connections time out sometime before then. So if you open your connection, it's running for 25 seconds and there's no data, then tear it down and open it again. So keep doing that every 25 seconds or so. Just another tip. Ideally, of course, you wouldn't have to do long polling. So browser vendors have been really good about this. We've developed the WebSockets, the standard. It's actually quite widely supported. And IE implements WebSockets as well. But there's a number of things to be worried about here as well. It's definitely gotten a lot better since the last year or so. But there's still some cases where it will just outright crash. So HTTP proxies, if you have a proxy configured on your computer, that will just outright crash if you use WebSockets for anything before 534.54. That's version of WebKit, I believe. So definitely check for that. And if you're below that, then fall back to long polling, because otherwise it will just result in random browser crashes. And the weird thing is the browser crashes only appear if you set proxies. So unless you're testing for that, you're not going to see it until like it goes out in the wild and someone actually does have a proxy configured in their network settings or whatever. The second thing is on mobile Safari, writing to a closed WebSocket also crashes. So if your socket is actually closed and you call ws.send, it doesn't like do an exception or anything, it'll just crash. So typically doing it in a set timeout helps. So having that little snippet of code there should help. Then Firefox creates ghost connections if you create new WebSockets. So there's almost never a reason for you to do this, but something to be aware of. In the close function for a WebSocket, if you try to create new WebSockets, that will just create ghost WebSockets. Like the connection will be open, but you actually won't be able to send or receive data on it. So, and this is actually a very subtle bug, and sometimes it's not clear that you're running into this because in the onClose handler for your WebSocket, you may not be creating WebSockets, but you may be calling other functions from your onClose handler that then create WebSockets. So the lesson is not to create WebSockets in that event loop of when the onClose handler is called. So always just wait for that. So the common theme here is whenever you're seeing a browser bug, at least I've noticed this, like always wrapping it in a set timeout will just magically make it work. But the key is to understand why. It's usually because something else happened in that event loop that's causing all these kind of behavior or so forth. So just something to be aware of. If you're creating WebSockets, always do it not inside the close handler for another different WebSockets. This bug may have been fixed, so a bug was filed. I haven't followed up, but this was at least the case until about 2 months ago. The other problem with WebSockets is mainly mobile networks. So when you're on 4G, 3G, or LTE, so mobile networks are incredibly, incredibly hostile. They do all kinds of messing with your packets to optimize it or whatever, or send it to the NSA. Like, I don't know, but it just seems like they're just doing all kinds of crazy things. And mobile networks are way more notorious at this than your regular fixed like Ethernet or whatever. So the trick that we've learned is just to almost now don't even bother with HTTP or WS, the insecure version. Things just get a lot better when you switch to SSL. So if you're serving your JavaScript and stuff, do it over HTTPS. And if you're doing WebSockets, do WSS. They can't mess with that, and everything goes cleanly. Again, your options are limited here because most corporate firewalls will only allow 80 and at least, thankfully, 443. So 443 is your way out. Try to stay away from port 80 as much as possible because the mobile networks do all kinds of crazy things with it. And especially with WebSockets, because WebSockets, it looks kind of like HTTP. And so the networks are going to think that it's HTTP and they're going to do all kinds of weird stuff, but it's actually not HTTP, it's WebSockets. And so there's just all kinds of debugging. So I will just save you hours of pain and just don't bother with it. Just go WSS, port 443. Don't even let them mess it. And SSL has gotten fast enough on the server side. So typically before, like if you asked me like 3 years back, the big concern was, oh, how do I do SSL at scale? It's going to be really slow on my server. But SSL terminators have gotten really, really fast. I don't think that's going to be an issue. So it's definitely worth doing that few extra milliseconds of the SSL handshake just to get around all these kind of network bugs. But again, WebSocket kind of works 95% of the time. So if you're really building a rock-solid production app, definitely always fall back to long polling. And again, do long polling over HTTPS and not HTTP, especially on mobile networks. So long polling is a very good fallback. I think XHR is widely supported. And in fact, IE is pretty good about this because they introduced XHR in the first place. So if you're using a wrapper over XHR, I think you're not going to have any problem. Cool. Finally, audio. So I actually thought this is actually really simple, but it turns out it's not. Just to play a sound file in a browser, it turns out to be kind of complicated. But just to sum it down, the summary here is if you serve every audio file in at least 2 different formats and use 2 different ways of playing the audio, the actual audio, you can cover all browsers. So the summary here is always serve your the audio files in the WAV format and the OGG format. So I'm talking about audio files that are typically short in length. So I do not recommend this for playing music, for example. But if it's just a simple, like if you're writing a chat app and you want to have a little ding show up whenever a new message comes, so serve those kind of files as WAV and OGG, and that'll cover all the browsers. The only browser it won't cover is IE. So in IE also actually the audio tag, the HTML5 audio tag, works, but only if you specify a doc type HTML, which will force it into modern mode and not compatibility mode. So the audio tag doesn't work in compatibility mode. So if you want to target, so for some reason you can't include the doc type in your HTML, and you want to target IE8 and before, then the BG sound tag actually works pretty fine. So BG sound is another one of these tags that you probably, or I hope that you haven't heard of. It's very old, but it actually does work very, very reliably on IE. There is one problem with using the BG tag, though. The BG sound tag does not let the user control anything about the sound, like the volume or whether they can mute it. So it can get really annoying, so I only recommend using it for, again, very, very short sounds that are not that interruptive. So combination of BG sound, audio tag with OGG and WAV will get you all the way there. So that's how you do audio in the browser. Any questions so far? Yes. MP3 as well, yes. Yeah, you can definitely do MP3. MP3, though, Firefox doesn't support MP3. I believe Chrome does.
Right, so yeah, Chrome uses MP3, and then I think Firefox is not already WebM.
WebM, yeah, WebM is good. OGG is also good. So actually, that's a good point. So thinking about the formats, so of course the browser support for formats changes over time. There was some discussion about should Firefox allow MP3 decoding and so forth. So it's always good not to hard code which browsers support which formats. So there's actually this useful can plate type function on the audio tag that you can call to check to see, hey, does this browser support this kind of format? And so I recommend doing this kind of runtime checking as opposed to having a static list, because then when Firefox adds support for MP3, and MP3 is a more high fidelity version when compared to Wave, then you don't have to change your code because it'll just work, because can plate type will return true at some point in the future, and then you can just upgrade to MP3 without any code changes. You had a question? Yes.
Oh, I don't know. I was just going to comment that you can use Flash to play MP3s.
Flash, yes.
So.
Yep.
Also, I think Firefox got support for MP3s everywhere except Windows XP.
That's right. Yes. So that's what I meant. So Firefox recently added support for MP3. It was really. So Mac and. It's not turned on Mac. So Linux and Windows. Okay. Cool. So that's the state of audio. Let's move on to WebRTC, which is kind of the newest API. So this is the one where you, if you're looking for cross-browser support, don't use WebRTC right now. That would be my my suggestion. But there are some excellent fallbacks that are available. So Get User Media is the API that lets you get access to the camera and microphone, and that actually works in Firefox, Chrome, and Opera. So that's fairly good, but it will not work on IE. It will not work on Safari. And Peer Connection has even lesser support, and that's the API to do network transmission of streams to transmit audio and video over the network, and that's supported on Firefox and Chrome. So the APIs are still in flux. The API is changing. Browser support is not that widespread, and there's just all kinds of minor incompatibilities, so you definitely almost need a shim layer every time. So I recommend using simple WebRTC.js. It's built by the Andiet folks, which is reasonably nice. And if you're looking for wider browser support, I highly recommend using OpenTalk, which actually has a Flash fallback. So on browsers like IE and Safari, so you've been able to do video through Flash before WebRTC came along. So it's always good to have that fallback if you're looking to do kind of cross-browser WebRTC. But again, WebRTC is one of these APIs that are still very much in their early stage. So for early adopters, it's fine. But if you're trying to build like a really production-level hardcore app, then I would not recommend it. And I think this is the final topic. So graphics. I was really surprised when I did some research for this. Canvas has amazing support across the board. So if you're looking to do any kind of graphics, definitely go for Canvas. IE has excellent support. Firefox, Chrome, Safari, and even on mobile, Canvas works really, really nicely. So I was actually surprised by how widespread the support is. And it's really good too, like the APIs. And there have been a lot of good libraries that are built on top of Canvas to help you do higher level things. Like if you're building a game, there's a game engine that you can use. So if you're trying to do anything that's graphics related, definitely Canvas is your best bet. It is not supported on IE8 and previously, so you can use a wrapper again that relies on Flash, like Flash Canvas. So definitely go for Canvas. If you're looking to do 3D graphics, WebGL, then probably not if you want to do want to support IE in your app as well. Chrome Frame I can add support to IE. I think IE9 also doesn't have WebGL. IE11 does. So 11 onwards is when you can rely on WebGL. But that's great that IE actually. So I assume that it'll in a year or so you'll be able to rely on having WebGL across the board. But at this point in time, so IE10 and previously, no support for WebGL. There's actually one interesting workaround here that I would encourage you to look at if you're interested in graphics at all, and that's a framework called Famous. And I think they had a keynote at HTML5DevConf where they announced the framework. And I really want to call this out because this is a very, 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 very interesting framework. So let me spend some time on explaining how it works. So you're looking to do graphics. And it turns out graphics is just all about projecting whatever 3D image or whatever you have onto a 2D surface. And typically what that involves is just a lot of math. And not just any math, but specific math, which is matrix math. And what's really interesting about this is that browsers, when they're working on their JavaScript engines, you have the SunSpider framework and all of these benchmarks that measure browser performance. A lot of them do matrix math as the base. So browsers have gotten very, very, very good at matrix math. They're very fast at this. And it turns out that's really what you need to build an entire rendering engine, right? So Famous takes this very interesting approach where they treat the DOM as a canvas. So like think of it like so this is overly simplifying it. It's certainly not how Famous works, but conceptually, you can think of the DOM as just divide the DOM into small div tags of 1 pixel wide each, right? And so now you have a canvas that you can draw on. And so now you can take any kind of like high-level graphics concept like a 3D image so you do all the matrix math to convert that into a 2D projection with textures and whatnot, and then paint it onto the DOM. And that's actually really, really fast. And so I was super amazed at how fluid Famous is, even on mobile, on old desktop browsers, and that's because it doesn't rely on anything other than fast matrix multiplication, which browsers are actually really good at, because that's what they've been optimizing for as a result of the SunSpider benchmarks and all of that stuff. And it just uses DOM operations. There's no required for plugin. There's nothing. It's just like turning on and off pixels really, really fast on the DOM. So I think that's a very, very creative and innovative approach. So if you're looking for wide browser support that's also actually really performant as well, definitely look into Famous. So that's that for graphics. So I think that covers the big pillars that I wanted to cover. And again, like I said, I didn't get comprehensive into any of those, just to give you a taste of what you guys can expect when you're looking to build an app in any one of these areas. Some other things that I would like to point out, the tools to help you build stuff. So definitely, so hopefully I have convinced you that it's not easy when you're trying to use any one of these APIs. What I recommend is, if you're building a new app, is to let other people do the work for you. So try to think about what is your app actually trying to accomplish. So think of if you can use a framework that is at a higher level than just using the direct browser API. So Famous is a good example of a higher level abstraction over doing graphics in the browser. OpenTalk is if you want to do video conferencing in the browser, rather than messing with the WebRTC APIs, implementing the Flash fallback yourself, just use the OpenTalk API, right? And Box2D is another good one for doing 2D graphics and game. It's an entire game engine, so you can do all other kinds of physics, collision detection, and so forth. And then Firebase for doing like networking and data synchronization. It uses like WebSockets, and it falls back to long polling automatically, so you don't have to build all that yourself. But also the lesson here is also hopefully encouraging some of you to build libraries that help other people, like these libraries for some of the other things that I mentioned in the slides, to do all of this like abstraction away from the different browser APIs once, and then put it up on GitHub and just help other people build on top of that, instead of everyone trying to cover the gaps in browser implementations. And also start with a good template. So on the front end side, there are a lot of good tools. HTML5 boilerplate, Modernizer, Bootstrap, jQuery. These are all, like I said in the starting, jQuery, like just no-brainer if you're trying to do anything with the DOM. It's just very, very good. And jQuery is really special in this respect, because some of the methods that it introduced became so popular that then they had to go back and tell the browser vendors, like, hey, implement like query selector. That's how query selector is now a native thing in the browser, and it's much faster, and jQuery is the first one to like provide that API. So just encouraging you guys to think about how you can build on top of the browser, and definitely browser vendors are listening. So if you come up with a really good API that's an abstraction over the stuff that's in browsers right now, there's always a chance that it will go back to become a native API, to become much faster. And then when you're trying to evaluate whether or not to use a certain feature, I covered some of them, but definitely didn't cover all of them. There's lots and lots of things that browsers are working on right now. So I recommend these websites, caniuse.com, html5please.com, really, really good resources to check what the current state of the world is as far as any particular API is concerned. And then finally, the most important thing is, and a lot of people don't do this, and it's really, really bad, there is no way in which you can manually test your application across so many different browser versions, so many different platforms, and so many different like rendering engines and so forth. This is something that's clearly like automatable, and you should automate it as soon as you can in your project. Luckily, there are lots of very good tools available to help you do this. So there's Browser Stack, there's Test Swarm, and there's Browser Swarm. Basically, these are all tools that will help you test your web app under various different platforms, various different browsers, just to see like all your users are really seeing what you want them to see. And this is something that definitely needs to be automated. Don't rely on manual testing. Don't be like, oh, I'll just run it on IE in my virtual machine. I'll just run Safari on my iPhone and just test it. No, that's not going to work. You want to automate this, because there's just so many different versions, and there's differences in API and everything. So definitely test, and test. Testing is very, very important. And fine, that's all I have. So just a final bit of like a tip that I want to give you is, like, when you're writing your code, you want to separate out what you want to do with how you do it. So it's very, very important, because the way that you do it in a certain thing definitely evolves as browsers evolve and as the APIs change and so forth. So if you have this clean separation of concerns in your code, it allows for two things. One is you can always drop in abstractions that come up later that turn out to be better, like one of the frameworks that I mentioned earlier. But also if you've gone through all the work of abstracting away all the differences in the DOM or differences in the APIs that the browsers provide to you, if you have that code out in a separate place that's independent of your application code, then if you choose, then it's also very easy for you to take that code, put it up on GitHub, and start the next like jQuery, start the next simple WebRTC.js, and just help out the community as a whole. It's like if you're putting all this effort into filling the gaps between the different browser APIs. So just from a code architecture standpoint, try to keep these two things separate. And that's just a summary slide of, so definitely use iframes with all the caveats that I mentioned before. Definitely use WebSockets with long polling fallback, no problem. You can do audio with wave plus og with the audio tag and the BG sound tag. WebRTC, I would suggest waiting a little bit. Use a polyfill if you really want to, or use something like OpenTalk. And graphics, definitely with Canvas, you can pretty much go nuts. That's all I had. Thank you so much. Any questions? Yes.
Talk about the API for WebRTC.
Yes.
Who wrote that?
Yeah. So yeah, it turns out really, really incompetent people like myself. But the problem there is also trying to balance traditional telecom like needs with modern web. Like we want the API to look really modern web, but then you also want the system to interoperate with SIP and all these like legacy VoIP system that creates a lot of tension in how the API is designed. But yeah.
On the document domain,
Yes.
so can you do the iframe thing if you have a subdomain and then a master domain? Like say one on www.
Yes. JavaScript, yeah. Yeah, you can definitely do that. Just make sure to call document.domain equals the top domain.com on both these iframes and set the top level port to null by just doing document.domain equal document.domain. As long as everyone has a common ancestor, you can do it. Yeah. Yes? So there's some differences. So a couple of them are open source where you can actually grab the code. So TestSwarm is open source. You can grab the code and kind of run it on your own servers if you wanted to. But BrowserStack is more like a service in the cloud, so you don't really fiddle with how they operate. You just use their service and you submit like your web app to them, and they'll take care of running. And so the pros and cons there are, sometimes you want to have control over your testing infrastructure, so then TestSwarm is better, because if you want to run it on your own hardware, you don't want to rely on a cloud service, then that's better. But BrowserStack is better for scaling, because then you don't have to worry about how many test cases you throw at it. Like they'll take care of the scaling for you because it's in the cloud. So it really depends on what you want. I have not played around with BrowserSwarm a lot, but my understanding is that's also a service-based thing where it's not open source, but you can use it for free.